Good morning, everyone. Thank you for joining today's EAC webinar. My name is Jessica Mogelson, and I'm the Marketing Coordinator here at EAC. Today, we will be talking about what's new in Creo 5.0. We will begin today's session with an introduction of EAC, and then Bill Schlund, our Technical Account Manager, will provide us with an overview of PTC Creo, along with a product demonstration. At EAC, we are dedicated to help companies transform the way they design, manufacture, connect to, and service their products. We do this by offering engineering and design services such as software support, implementation, training, and product and part design. We have a range of products and services that we sell, including CAD, product lifecycle, and service lifecycle management software, as well as the Form 2 desktop 3D printer. We implement the Internet of Things and augmented reality into business strategies, offer help with design and engineering projects, and we offer training courses and webinars for continuous learning. We've partnered with PTC to deliver today's leading industry software, and we are specifically focusing on the PTC Creo and its new capabilities. With our wide product lines and capabilities, we offer a number of webinars to keep everyone updated with new features, tips, and tricks. Tune in on November 1st to learn all about what's new with PTC's Creo design packages. We also invite you to join us on November 6th to learn about the technical illustration capabilities needed to deliver 3D service content. You can find all of our upcoming webinar topics on our website at www.eacpds.com/events. With that, I'll pass it on to Bill to discuss the new features of PTC Creo. Bill, take it away.
Thanks, Jessica. Good morning or good afternoon, everybody. My name is Bill Schlund. I'll be going through Creo 5. For those of you that like numbers, Creo 5 is Pro E version 33, but I'll be going over a sort of what's new in Creo 5 presentation today. So to start it out, I'm going to kind of bounce back and forth between the PowerPoints and working with the software. To kind of overview things, Creo 5 covered basically 3 big areas where improvements were made. The first is productivity and usability, and that's usually consistent from release to release anyway. Then some additional capabilities have been added to additive and subtractive manufacturing. So additive manufacturing being 3D printing and subtractive being your typical 2.5 to 5 axis machining. And then also some new things have been added in the lines of simulation and optimization. So we'll be going through all of those in this order. So first of all, let's talk about productivity and usability. Some of the things that we saw in Creo 4 was the introduction of the mini toolbar. And that's kind of a context-sensitive toolbar. When you click on a piece of geometry, it pops up things that you can do with the type of geometry that you picked. And it's customizable. It's actually a really cool idea. What they have done in Creo 5 is extended that to a couple other modules that didn't have that. So we are going to see the mini toolbar pop up when we are in 2D and 3D annotations. Also, when working with the style feature. The style feature is also known as ISDX, or the Interactive Surface Design Extension. So it's a single feature, but it's a compound feature, so you can create a lot of curves and surfaces with that. But we'll see the mini toolbar working with that. And then we'll also see it with round and chamfer handling in flexible modeling. So as the system recognizes rounds and chamfers, it gives you a pop-up toolbar to make modifications through that. Then one of the things that was changed were the dragger handles. Basically, they made them a little bit bigger so they're easier to select down. They kind of changed their color. But again, this comes under the heading of usability. Another thing that was added, which is pretty nice, down at the bottom of the screen, there's always a prompt down there that tells you, pick an edge, pick a surface, or something like that. One of the things you can do is a config option, and you can attach that prompt to your mouse. So when you are prompted to pick a surface or pick a plane or something like that, that will pop up at your mouse tip and let you know that way. So really good for people who are casual users or new users to Creo. And then something new that's been added is the ability to search in the model tree. So we've been able to do that before in assemblies, right? You could search for parts, but now you can go into a part model tree and search for features or datums or whatever. So it searches by, typing in the name of that particular feature or type of geometry. One of the things it can also do is they've added some more capabilities to the show and the hide. So we can say show only, show all except, sort of things that we can see in other softwares, like I'm thinking of in particular Creo View, where we have the capability of just picking on a component and say show only that component. It's called isolate, but we can kind of do that now in Creo. So we're going to see this a couple different places where technology from other softwares that are in the PTC suite bleeding into Creo Parametric. The code's already written, so you might as well just slide it into Creo Parametric and let the users of that software take advantage. So we'll see that a couple other times here. There's a new type of sweep that was added. It's a 3D volume helical sweep. So basically it would be, in the example here, we kind of see a grinding wheel cutting a drill bit or a milling tool or something like that. So this capability was there in Creo 4. And what PTC did is they went and they checked on the geometry that's being created, and they go, it's just not quite right. There's something off a little bit with it. So they pulled it from being released in Creo 4. And then they went and looked at some competitive systems, SolidWorks and NX, and they looked at how they did these volume helical sweeps, and they made the exact same wrong geometry. So what the developers did in Creo between 4 and 5 is they modified the mathematics and the way that the software works to develop that final geometry, and now it is correct and available to us in Creo 5. Something else, again, talking about bleeding technology into Creo from somewhere else. One of the things we could do in flexible modeling, we could bring in a step file or a non-parametric file, and even if it had rounds on the geometry, we could still add draft onto the surfaces. And what it was doing in the background is it would turn those rounds or chamfers off. It would highlight them in green, saying, hey, I recognize these as rounds or chamfers, allow you to manipulate the surfaces, and then it applies those rounds and chamfers back on to those new edges. And so they've taken that capability and put it into regular Creo. So now you don't have to think ahead so much as far as when you put rounds on it. It's still a good idea, from a modeling, practices standpoint to do rounds and chamfers near the end of the development of the product. But in this case, sometimes you have to put rounds and things in early. This will still allow you to give you the capabilities to add draft onto surfaces that have the edges either with rounds or chamfers. And then finally, something has been changed with the mirror feature for mirroring multiple features, and gives you a better preview of what is being mirrored, and then also the ability to add and remove features of basically the list that you're giving it to mirror. So let's take a peek at that. I'm going to call up Creo 5 here, and we'll go through some of these things I just talked about. First of all, let's call this guy up. Here I have kind of this big red grinding wheel. This is my prompt, or kind of a prop that I'm using. But basically, this would be kind of the shape of geometry that I would use to cut a helical path on this workpiece that I have here. This would be kind of our drill bit, we could say. Now I could use this as my cutting tool, but what I'm going to do is actually create one from scratch so you can kind of see how that is. But I just wanted to show you that when this geometry removes material, it's different than just moving a profile helically around that, because the grinding wheel is cutting before where the profile would be and also after. So it does create a little different geometry than just your typical 2D profile type of a helical cut. So let's turn this guy off, and we'll go into our sweep. So under sweeps, because we have Creo 5, we have this option right here, volume helical sweep. So I select on that, and it highlights in red what you should be picking, but basically we're going to define our sweep profile. So I'm going to sketch on this plane here and say, let's start sketching. And we'll kind of square it up so we can see directly what we want to do. The first thing I'm going to do is sketch a line. And basically the line is, where does the helix start, and then where does it end? So how much is it moving along this line? So I'm going to say I can just start it here. I could start it wherever, but I'll say let's start it here and maybe end it there. So the length of this line, I'll kind of round this number off a little bit, is the helical cut will start here and will go in this direction, as you can see with the arrow, and will end at this length here. So that's our first way of controlling this. And as you can see, I could switch it to the other end so the helix starts on the back end and moves forward. Again, that's just a real easy thing to do. Our next step would be that we need to pick, and I'm going to have to turn on axes here, is it wants us to select an axis. And this would be the center axis of the helix. So once I have that, we can say that we've got our geometry placed here, and then this is what our helix looks like, right? So it's starting here, it's wrapping around, here is the axis that it's revolving about, and then it ends right there. You notice up here, we can either do left hand or right hand as far as revolving our helix. So I guess that helps the Australians maybe. But one of the things that we're going to do here is we're going to start creating some geometry. So you notice how it's kind of leading me down here, highlights the next thing where we want to do a sketched section here. And so what we want to do is say, let's create our sketch. And we'll take a look at it here. Now I'm going to sketch the profile of basically our cutting tool. So I'll just make it real simple. I'll just make it maybe like a rectangle. And we'll say, let's just come down maybe like this. And again, I'll kind of round this number off a little bit. So this will be the profile that's going to be helically revolved around here, removing material. Now it's a flat end right now, and I don't really want to use that. So I'm just going to come in and real simply just make a rounded end on this guy. Then we can remove these corners. All right. So this will be our tool that we will revolve. All I have to do is hit the check mark, and it creates our helical cut. I'll turn off the display of our helix here. We can see that this is the geometry that's created. Again, because we waited to get it done correctly, this is the correct geometry that's being represented here. Also, I can go in here and say, I want to change the pitch and maybe make it 6. And again, we see the geometry updating accordingly. So we can see there's a lot of things here we can modify. Obviously, the pitch, the length of the cut, the distance between, the length of the cutter tool, things like that. So a lot of things, but it creates some pretty cool, complex geometry, as we see here. Again, not something to use every day, but if you do need it, it's really, really good tool. So let's move on, take a look at something else. We'll take a look at rounds and chamfers. So here I have a couple of example components here, and what I want to do is add draft to those. Here I have rounds along the top, and I have chamfers along the bottom. And one of the things that we can do now, thanks to Creo 5, is, and I'm just going to say, let's grab a surface here. Let's grab this surface, and let's continue grabbing maybe all these vertical surfaces here. All right, so we want to put draft onto all these guys. And so our draft hinge will be right here. So the first thing we see, and here's our new drag handles, right? So they're a little bit bigger, easier to see, is that we can start putting draft on here. But it's highlighted the rounds and the chamfers, both saying I recognize these as geometry that's going to have to be, manipulated a little bit. And now I can pull the draft out or pull it in. We get a really good preview of how this works, and then we can come in and just select that. Let's go in and let's add draft maybe on this other guy, same type of thing. Again, this one is, I just use chamfers, but I use different types of manipulations in the chamfers for, let's pick these guys. We'll pick them as our draft surfaces. Again, our hinge, this time we'll maybe pick the bottom. But again, as I drag this, even though we have kind of different transitions in the chamfers in this case, or it could be rounds, it doesn't matter because all it does is in the background, it's pulling them off, putting in the new geometry, and then putting them back on. Before, what would screw us up is actually the edge identifier numbers would change, right? Because that edge now is different, and so the rounds, you have to reroute them or something like that. Now you don't have to do that anymore. Makes it kind of nice. So another thing that I was talking about, well, let's go and put in, let's say we want to put a hole in here, put it on this guy. So here we can see, again, the change with the drag handles, again, to control the diameter. But then here are the drag handles. They used to be little green boxes. Now they're just a little bit different, so we can kind of control where that's dimensioned to, and then put in our hole that way. But one of the things I wanted to highlight as well is searching in the model tree. So I have multiple features out here, right? Some datum planes and things like that. So I can start to search in the model tree. And what I can do is say, let's look for rounds. So I start to R, and it highlights everything that has an R in it. Then I say RO, still everything that has an R and an O in it, which is our front datum plane, and then some rounds. ROU, it grabs all our rounds. So you can see it kind of narrows all that down for us. And what I can do is then grab those, and I can redefine them or change the references. So it's just kind of a way of grabbing things real easily by kind of type. And speaking of types, in this case, we have some datum planes. So I can pick on a datum plane here. And you notice now, there's only, in previous releases, there's always just a show or a hide. So I can say, turn on that datum plane, like we could always do. But another thing I can do is I could say, show everything except that datum plane. When I do that, all datum planes are turned on, made visible, except the one that I selected. And then if we wanted to hide this guy, I could say, hide him. Another thing I could do is say, show only this datum plane. And so he's displayed right over here. We can kind of see it on the right side. One of the things I noticed, there isn't a hide all or a show all. So you have to do it kind of in 2 menu clicks, show everything except this thing and then click that thing. But anyway, new capabilities. And actually kind of highlight that a little bit more, I'm going to go over and say, let's open up. Let's see here. Let's go into our mirrored thing. So here we have some features, right? We can see those here. We have a cut and some holes and some chamfers and things like that. And what I'd like to do is select those and then mirror them about this plane onto the other side. So some of the new things with Creo 5 is that we get a better preview of what this is going to look like. And then also we can control a little bit better which things are getting mirrored. So I'm going to grab the cut, which is the main cut, and the hole. And let's grab all the holes there, right? So basically a bunch of material removal features I'm grabbing. And when I have those, I could say, let's mirror those about this plane. So it gives us a really good preview now of what we get on the other side. And over here under references, we can kind of see these were the features that were mirrored. If I don't want one of these guys, I can just say remove him. And you can see that it's been removed right here. Still in the original, obviously, but it didn't get mirrored over. One of the nice things about this too is if I do have mirrored a bunch of geometry, if I go back and say I want to redefine this mirror, here are references. You notice they're grayed out. I can't select any of them right now. But I go up here, I say reapply the mirror, and now I have access to these features. And what I wanted to do is actually include this chamfer. I'd forgotten that. So when I click it, I'm holding my control button down to add it to the list. I pick him. Now the chamfer is added. We can see that it's also added over here, but not the hole. Remember, I removed him. So it's really nice as far as if you ever have the occasion to mirror multiple features and maybe we want to change exactly what gets passed over to the other side of the plane. Gives you very good capability for doing that. So let's go back to our PowerPoint here and talk about some more capabilities. Something new that's been added, again, some more technology that's been brought in from other packages. This would be from Creo Direct, which is kind of the non-parametric version of Creo. What it has is a capability of you could have a real complex sketch with lots of overlapping geometry. And what it does is it can grab those intersected closed areas and use those as a sketch region. So that is really kind of useful. You can create, instead of creating multiple sketches, you can create a single really complex sketch with lots of overlapping geometry, and then use the overlap sections, as long as they're closed, to create the geometry you want. Another thing that has been added with Creo 5, this is under the Unite capability. So again, the capability that everybody has to open up native. So far, you know, it's SolidWorks and CATIA and NX. Now we can add Inventor to the list, so we can open those up natively. Previous to this, they would be kind of converted on the fly and brought in, but now they stay in their native format. So this is a new capability that's been added to Creo 5. One of the things in you know, non-disclosure type of thing to make sure that we're on the level is that you cannot write out an Inventor file. You can write out, there's a collaboration extension, right, that allows us to write out a CATIA file or an NX file or a SolidWorks file. This capability for Inventor has not been added to that yet. So we can only bring in Inventor files natively. We cannot write out a native Inventor file from Creo or something like that. And then some new capabilities have been added to sheet metal, and those capabilities allow us to do a flat pattern rep. So you could do a flat pattern rep before, but really the way it would treat it is that the master rep would be the flattened version, and then the representation, the other rep you made, would be the bent up version. People usually didn't want it that way. They want the master rep to be the bent up version, the fully formed version, and then the new rep to be a flattened version. So that's been added to Creo 5. And also some new capabilities for corner reliefs and some new enhancements with the conversion tool. The conversion tool basically being, I'm bringing in some step file or some solid geometry, and I want to convert it into a sheet metal part. So it does kind of a shelling operation. Then you can pick on edges, and it puts rounds and things on that. So let's take a look at these guys real quickly too, while we have Creo up. So first, let's take a look at our sketch regions. So you notice here, I have a sketch right here made up of multiple geometries, I guess. And I also have an extrusion. I have the bottom surface. Now, because this surface lies on the same plane as these guys, it is also able to be picked in our closed area selection. If this was like a both sides extrusion, I wouldn't be able to pick the bottom surface there. But let's see how this works. So because I have Creo 5, down here in my filters, I have this thing called sketch region. So this is new. And I can come over there, and you'll notice that as I pass over these little areas, it just highlights the different sections. And because, remember, like I said, this solid geometry is on the same plane, I can pick closed areas where this sketch basically intersects him. So what this means is I could pick maybe this section right here. I can pick on this, and I'll say make a fill surface about it. So now I have a surface created from this geometry. I could come over here, pick on this, and say let's extrude that, and we'll maybe flip them the other way so it removes material, and now we've got a cutout of our solid geometry. I could pick on this guy, and I could say let's revolve him around this edge and make kind of like a little Hershey kiss or something. So as you can see, I can create a single sketch, and from that I can create a lot of different geometries from that. So again, makes things a little bit more efficient. Here I have a folder, and I'm saying file open, and we see nothing here listed. So I'm going to go under here and say search. And I'm going to go down here and say, let's look for Inventor files. So there's an Inventor file there. So I'm just going to say open it up. And it brings it in its native format without converting it or anything like that. You'll notice that it has over here the symbol indicating that it is a non-parametric file. It's a non-native file. It also has the capabilities still of working with the ATB. So if this file were to ever change, I could say read in the new file or update this file with the new version, and it would all update. I can still reference it and use it. I can add features to it. Again, if I add features to it, it'll convert it into a Creo file and then put the features on it. Or we can leave it in its native format, and it creates a little side file, a .creo file, that adds all those features to that side file and then keeps it in its native format. So it works the same way as Unite does with the other applications. So let's go and take a look back at our, oh, sheet metal is one other thing I just wanted to touch on. So let me call up a sheet metal part. Let's just make one. I'll say okay. So here's our sheet metal part. I'm going to grab a couple edges here just so we can kind of highlight some new things. I'm going to pick these two edges and extrude those out. So this is basically, you notice we have new drag handles here. I'm going to come in and take a look at this. So one of the new things that has been added in Creo 5, if we go under relief, we can go to corner relief. And under corner relief, we can see, and let's kind of move this guy over to the side here, we can see that we have circular relief. So that wasn't there before. We can go in and we could say, let's do square relief. We can see it like that. We could say rectangular. So new options that have been added. Basically, the square and the round have been added to this. So that's something new in Creo 5. The other thing that I mentioned is making a flat version of this and making it a rep, a simplified rep, instead of making a family table. So same thing that we see before. I can see the flattened version here. We can zoom up. You can see our little rectangular relief here. But one of the things we could do is we can make a family table, but here I want to create a rep. So by doing that, here's our rep name. We'll just take the default, and it flashes real quickly for us, but here's our master rep that we're looking at here. And if I go under reps, we can see here's our flattened version. I double click on him. We've got the flattened version. So master rep is fully bent. So something new that's been added to Creo 5 for the sheet metal guys. Let's move on to our PowerPoint. Something that new has been added is the ability to work in Creo in a perspective mode. The ID guys have been asking for this for a long time. And so now we can, just a switch, you flip, just say I want to work in perspective mode, and your model is then viewed as in a perspective view as you're working on it. So it's just like a light switch, you flip it on or flip it off. Another thing that's been added is with the freestyle feature. Again, the freestyle feature is a feature that everybody has, and it allows us to do a subdivisional modeling. But one of the things that was added in Creo 4 was the ability to import OBJ files. So allows us to bring in another mesh from another product and create the geometry for subdivisional modeling using that. One of the things now with Creo 5 is that you get a good preview of that imported mesh, and you can edit that mesh for changing the normals and things like that, so that when it creates the geometry, it creates it the way that you want. Also, another thing that's been added, you know, when it initially started out, you could align your subdivisional model or surfaces to a plane, and then you could align them to surfaces, and then you could make them tangent to surfaces. And now with Creo 5, we can make them G2 curvature continuous to any surfaces that they blend into. And then also there's something called box creation mode. So this usually would be useful if you start creating more of a complex part. As you see, as we can see in the middle image here, there's a network around our geometry that we're creating. And the network is what we really edit. By pulling on the network, pulling on the edges and the vertexes and the surfaces, that manipulates the geometry. Well, sometimes when it gets really complex, it's hard to really see that network. And sometimes the geometry and things are overlapping. It's kind of hard to get at it. So we can flip to box mode. And basically what it does is it shades in that network. So now it's very clear to me as a user exactly what that network looks like. And now I can pick on the surfaces or the edges I want and make those manipulations here, and it still changes the geometry. But it's just a different way of displaying the network, kind of shading it so we can see it more clearly and maybe be able to get at it a little bit more easier. And then finally, our third one I want to talk about here is working with KeyShot. Now we've incorporated, KeyShot does a lot of things very, very well as far as photorealistic rendering. One of the capabilities we brought in Creo 5 is to do real-time ray tracing of that. And another thing that PTC did is they've made it an app. So by an app, what I mean is it's a standalone application. So I can start up this little KeyShot app all by itself. It's not bringing up Pro-E, it's not using a Pro-E license or a Creo license or anything like that. And then I have to say file open, and then I bring in the geometry, and then I can start doing the rendering with it. Just like Simulate has an app where you can call it up and it's just Simulate all by itself. Nothing else is there. So you have to say file open, bring in the part that you want to do the analysis on, and then start working with it. So it's a little standalone app that's been added now with KeyShot capabilities. So let's move into our second area, and that's additive and subtractive manufacturing. So first of all, just to kind of highlight something that PTC does that doesn't really get talked about too much, is that the strategy is, when it comes to 3D printing, additive manufacturing, is that we want to keep the user inside the Creo environment the whole time. So while you're designing the part, while you're optimizing the part, validating the part, and 3D printing and checking the part, all that is in the Creo environment. A lot of other systems, you have to go to different softwares, you have to switch modes, do all this type of stuff. With Creo, we stay inside the same environment the whole time. One of the things that's been added, when Creo 3 came out, we had direct connections to the Stratasys systems. When Creo 4 came out, we had direct connections then to 3D systems. That was added to it as well. And now with Creo 5, we've added materialized systems. So materialized is a little bit different than the other two. It not only would do polymer or plastic parts, but it also does metal parts. So that is kind of a unique capability now available to Creo users. This number down here is kind of a marketing number. I would say, like with these three, these are kind of the three big dogs in the industry. Probably 2/3 of all the printers that are out there, we can now directly connect to. And that means aside from just sending in an STL file. Some other things that have been added in the Lattice is that it has different cell types, and there were cubes and triangles and pyramids and things like that. Now there's a new truss cell type that we can use for making our network here. One of the things that also has been improved is the simplified visualization of it. So before, when we create this as a solid piece of geometry, it takes extra time, right, to create this whole mesh in here. And so one of the things we can do is say, we'll display it as a simplified representation. And it would do that, but it would just display it as lines and circles and things like that. It would make it really, really simplified. And again, that's so you didn't have to wait for it to generate this. But one of the things that we can do now in Creo 5 is we can say, show us the lightweight simplified version of this, and it will show us the 3D solid version of it, although super lightweight. What that means is we can still get the volume of it. Before, when it was just lines and circles, you can't get a volume of that. But now when it shows it as basically kind of like a 3D solid, more of a lightweight version of it, you can get a volume from that. So without having to have it go and create the topology for all this, we can get kind of a real good idea of what the volume of that particular part would be. In addition, there's support for conical beams. Now, we could do conical beams before, but they're always shown as a cylinder. They take kind of the average and make a cylinder for us. So now it shows it as a real conical beam if you needed to do that. So talking about metal printing a little bit, that is a new extension for being able to do that. Metal printing is a little bit different than polymer printing as far as the support structure, and that's kind of what we see in the middle image here with the yellow supports. Now, if in the polymer world, in the plastic world, the supports basically just hold up the part, right? That's what they do. But we're working with metal, there's actually things that we have to take into account, like temperatures and things like that, heuristics. And what we need to be able to do is control these supports a little bit differently than we would with your typical kind of plastic printer. And so what Creo 5 does is give you the capability to edit those particular supports to take into account heat buildup and things like that, because it can actually deform or make the part not exactly as intended with those typical heat rises and things like that taking place. So this allows us to manipulate those supports to take that type of behavior into account. So speaking of manufacturing, and now we'll kind of move into subtractive, or 2.5 to 5 axis machining. One of the things that has been changed in Creo 5 is that the tool path that we see in the model tree is now treated like a real feature. So if we pick on it in the graphics area or in the model tree, it highlights in the other. It also shows you the references that were used. So it behaves like a real feature because it is a real feature. So they've just extended those capabilities and characteristics into the machining features. Something for coordinate measuring is they've changed the interface, not a total 100% revamp, but all the major components and commonly used capabilities and functions have been morphed into the ribbon interface. I remember when this came out in Rev 17, it was it had the old style menu interface, and so now that's being replaced by the new modern, easy to use ribbon interface. And then another thing that's been changed with, in this case, volume machining and regular 2.5 to 5 axis machine is we can do slice by slice volume milling, and then also a tricoidal tool path along curves. So tricoidal, the tool actually moves along the curve or the edge in a series of circular motions. So it's a little bit different than just moving directly along an edge or a curve. And what this does is it allows you to use the same tool to create a variety of different shapes, and it lends itself really well to high-speed machining. So a new module has been added, and there's a product that's been out there called ModuleWorks, but they've been out in the industry for quite a while. And what PTC has done is brought that capability into Creo, built it into Creo with the ribbon interface. You just say, I want to work with this new Creo mold machining extension, and this capability pops up. So again, we've seen this in other capabilities, certainly going back to even like tolerance analysis and things like that, where we're grabbing other people's software and kind of embedding it into the Creo environment. Now, what's good about, and I think I have a movie, so we just don't have to talk about it, but what's good about this ModuleWorks is that it's really good. Regular Creo machining is very, very good for creating and optimizing a toolpath for really production machining. And we can do a lot of one-offs of that, or not one-offs, but similar parts, where we can kind of morph or apply the toolpaths onto, family table of parts or something like that. It's very, very good at doing that. But a lot of times in the mold industry and industries where they just want to create kind of one-offs of different parts, they just want to remove all the material as quickly as they can and then get on with it. So that's where ModuleWorks comes in. That's where it's really, really good at removing a lot of material really quickly in a really good, easy, simple to use interface. So like I said, it's been out in the industry for a while. We're just leveraging that capability. So again, not purely just for the mold guys, but it does kind of lend itself really well to that type of industry where we might only be creating, like I said before, kind of a one-off or something that, we don't create 10,000 versions of it. So also, this certainly has the capability of what we saw before is, kind of showing the material being removed, like we see with, just the regular Creo manufacturing packages. And we see the cutter location file over here on the right side as well as it's going through and removing the material. So again, that was from ModuleWorks. Kind of close this guy out. And let's talk a little bit about simulation and optimization. So we'll go over a new module, again, borrowing technology or leveraging technology from another company. Simerix has been out there as a CFD, computational fluid dynamics partner of ours. One of the nice things about this, again, we can kind of watch this how it works, but it's fully integrated into Creo. What it's doing is it's giving us the capability to do CFD on assemblies and parts, whereas previously we would have to go to a kind of a third party. Now it's built into Creo using Samaric software. The nice thing about it, so watch this, it kind of does surface and bounds. So you work directly on the geometry. Here I'm picking that surface of this thing and it closes it off right there. So once we close off everything, then it can figure what is the volume of that's going to be our fluid, and it knows where the solid stuff is. So it basically works directly on, we don't have to go into any weird mode or do any translations. It works directly on the geometry, solves really, really fast, but it figures out what the volume is, and then we say, okay, this volume is air, or it's a liquid, and it has this temperature, and it's flowing this fast. So it starts to do that type of analysis, and like I said, it solves really, really quickly. And we can see a variety of different things. With this, we can see flow lines, we can even see particles and things like that. It gives us a real good feel. It's like Simulate or Mechanica, going back to the old name, in that it was meant for the average user. So there's a couple different flavors of this, but the basic release, the basic level, it is very, very easy for just a common user because it closes off the volumes. You give it the different material that's flowing through there and the speed, and it gives you the representation. And like I said, you can see the flow lines, how the things in this particular example, in this particular power supply, how the air is flowing not only around the component and through, but you can also take into account thermodynamics, right? So now that we got this air flowing through it and the air is this temperature, how does it cool down the PC board as it travels over it? So it does all of that. Like I said, there's 3 different flavors of this. So here is the basic capabilities, then there's an analysis plus, and then a premium. So the regular analysis is, like I said, for guys like you and me. So all we have to do is really close off the volumes and give it the kind of fluid that it is, and it runs the analysis. And then we can start to do some more advanced things, and that's where we start getting into particles and radiation and species. And then finally, we can go into the premium level where we have cavitations and multi-phase and things like that. Again, when we start getting up into the middle and the upper level, we're talking about people that spend a lot more time with the software and are geared a little bit more towards the analysis field rather than your typical engineer. But again, the nice thing is that we have a menu of capabilities for anyone. So really nice capabilities have been added here with Creo 5. And then something new, I don't bypass this, is called Topology Optimization. And I'm going to show you an example of this, how this works, but it's a little bit different than what you might think. So PTC has always been able to optimize topology ever since '96, right? As that's when PTC bought Mechanica. And what that has been able to do, really what that was it was optimizing things based on parametrics. So, you know, I would make a hole bigger, or I'd move a hole, or I'd make this little tab longer, or something like that. That's how we would optimize things parametrically by numbers. What this optimization does is it removes material. So it's like taking a chisel or a Dremel tool to your part and removes material that way. It lends itself in a lot of times to 3D printing because it can create some pretty wacky geometry that you wouldn't be able to manufacture your typical way, your machining or blow molding or casting or something like that. But let's take a look at how it works. So I'm going to come down here. And we're first of all going to go into topology optimizations. Like I said, it's a new module, it's a new application. So I'll click on that. And you'll notice what it does is it's showing me some different loads and constraints. So by removing material, it just doesn't randomly remove material. We have to say, well, there's certain loads, there's certain physical properties that this needs to be able to deal with, right? So it might be constrained this way, it might be loaded that way. So remove as much material and still allow for, you know, a deformation of only so much or something like that. So that's kind of how this works. So in this particular example that we're looking at here, this is actually a component that's part of a mechanism. And so this is part of multiple other components that are moved. As you can see, there's some loads here, some forces, and there's basically a rod that goes through the center of here, right? Over here, it's constrained. So this guy is, fastened to another component. And down here, we have a constraint, so it's fixed from moving here. But then there's also some forces from another part. So this outer surfaces out here are actually rubbing on some other components, or other components are riding along those. So these are all the different loads and constraints. And again, this is brought from mechanism dynamics, where we can do that. We can just pick surfaces and constrain it and load it the way that we want. In this particular example, it's just brought in from that capability. But one of the things it does is we create volumes, all right? So we see there's some volumes here. As I move in my mouse over them, we can see them highlighting in different areas. That tab is a volume, this bottom area is a volume. Now, in typical FEA analysis, when we specify a volume, we might say, well, this volume has different material in it, or this volume has a different density of mesh or something like that. In this case, when I specify a volume, it's like, don't mess with this geometry. You can go ahead and hack at the other stuff, but leave these guys alone. So we want to leave that tab there. We don't want it to be all whittled away to nothing. And we same with the bottom area down here, because there's a couple surfaces that other components are relying on to be there. We don't need those to be removed. So we'll specify volumes as kind of like keep out areas. Don't mess around with that. And again, we can kind of see the different loads and constraints. Again, in this case, we could have created them by hand. In this case, we brought them in from mechanism dynamics. So I'm going to go over here, and I'm going to go and say, show me the results. And I could have meshed it too. It does tetrahedral mesh, so it does a bunch of tets on it. And then it takes that, and it creates this, right? So it's removed as much material, still taking into account. You notice the red areas, our volumes, have been untouched. But it just emasculates this thing, just removes material, but it still has the strength that we require. We could go in here and we could say, let's kind of make that go through its motion. Again, it's magnifying the amount of deformation here. We can actually put the part around it if we wanted to in that case as well. But we'll look at it at this point in the end of form. Now, other systems out there, competitive products, do geometry optimization as well. And this is pretty much what they give you, right? They all kind of work the same. And they say, okay, here you go, make a part out of that. It's a pretty hard thing to do. Would I start stretching surfaces over this? Do I have to start drawing curves and then make surfaces? I mean, it's going to be kind of hard to work with. This is where we kind of shine in this particular area. So what I'm going to do is I come over here and I say geometry reconstruction. And what it does is it takes the style feature, which everybody has, right? And it creates those surfaces as style features. So we can look at our component here. Here it is without those style features. And I just come over here and I'll say, let's take a peek at them. And here they are, right? So these are the areas that are going to be removed. And so I can kind of take a look. Let's look back at this guy. Over here, I can kind of see, this kind of comes right down. We're going to have a real thin wall here. I don't really like that. So I'm just going to drag a box around it because it's a style feature and just drag it up. Now, I'm not affecting it. If anything else, I'm adding material to it. I'm making it a little bit stronger. So as long as I'm kind of making things smaller, I can kind of manipulate things. Over here, I have a little divot out of the corner. I don't even want that there at all, right? So I can just grab that and say delete. It gets rid of it. Now, here's what I was meaning before when I mentioned that it lends itself sometimes to 3D printing. Here it's made a pocket. It doesn't even go through the other side. Just some kind of weird little pocket. And we don't need that material, so it's removing it. I don't want to have a hole in my part like that or a pocket. Who knows, it gets stuck in there. So I'm just going to delete that as well. So now that we have what's left, I can just go in and say, all right, let's make our part out of that. So here it is with those style features. And I can come over here and say, let's make solid geometry out of it. And now we have a solid part. If I ever need to go back and change something, I can just pick on this, say edit definition, brings us back to the style feature. And now I can continue, going in and manipulating geometry the way I was before. So really, really kind of nice capabilities here, working with this Topology Optimization. And like I said, it really can make some wacky geometry for you, but it is removing all unnecessary materials. So if weight is a concern, this is actually a really good tool to have available to you. So let's go back to our PowerPoint here. That kind of brings us to what I wanted to cover. Now, there's one thing I just want to touch on real quickly. And you'll notice that Creo 5, right, came out in March. Creo 6 is going to come out March of 2019. So this is like unheard of, right? PTC releasing software every year. And that's the plan. They're going to release software every year. So we can kind of see how things were released here. Now we got Creo 5 coming out in 18, Creo 6 in 19, Creo 7 in 20, and so on and so forth. But what they're doing is they're going to have a series of major releases and minor releases. And this is actually to help the customer base, because there's a variety of different people that use Creo. So minor releases, which would be Creo 5 and Creo 6, will be considered more of a minor release, not a lot of things added to it. And what those would do is for their first year, they'll probably have about 3 to 4 maintenance builds. And then they'll slowly kind of maybe only have 1 or 2 the year after that, and then they'll be stopped supported. And then, so these are intended, these minor releases are for smaller companies who are more agile and want to adopt new technology right away. And it's a lot easier for them to just go and switch releases than for the larger companies, right? Where they have to do, a year's worth of analysis and testing it and interacting with their systems and all that to make sure it really works. So Creo 4 was the last major release. Then we'll have a couple of minor releases, and then Creo 7 will be the next major release, and then so on and so forth. So you can see Creo 4 goes all the way out to 2021. Creo 7 will go out the same amount of length. So the minor releases aren't supported as long, but that's because they're expecting these companies to kind of switch from release to release. For the bigger companies, a little bit more slow moving as far as just because of the big load it takes to switch from one release to the next and to make sure that it works with all their other systems. They can just move from one major release to the next major release. They can wait a couple years in between, just making things a little bit easier. So we're basically, PTC is basically allowing this new type of regiment to help both types of companies. And then one other thing you might have noticed is a naming structure, right? So the current version of Creo 5 that's out right now is maintenance build 20, right? So there's 3 numbers after this. So in the current version, the latest version will be 5.0.2.0. So what do these other numbers mean? The second number after the 5 in this particular case is a point release. So Creo never has a point release. We're never going to have a 5.1 or a 5.2, but Windchill does. Remember they had 10, 10.1, 10.2, 11, 11.1. So those point releases, so these naming structures go across all softwares that PTC has. So the point releases would be the second number. The maintenance release would be the third number, right? So this would actually be a 2, as we see down here in our third row. And then finally, any critical patches or hot fixes would be the last number. Again, there's no critical fixes or hot fixes, patches for Creo, but we do see that in other softwares, right? Windchill and things like that. So that's kind of the numbering scheme as well. And we'll see that across all softwares. So just be kind of aware of that when you start seeing numbers. As Creo people, we're interested in the first one and the third one, right? Major release and then the maintenance build. So with that, that brings me to a close of what I wanted to cover. And Jessica will open it up for questions if you have any. I'm here to answer those for you.
Bill, I do see one in the queue. Someone mentioned they see a 3D sweep always demoed as a helical sweep. Is it available using a 3D trajectory sweep?
It's a helical sweep, so we are limited to that type of capability. Yeah, it's not like a multi-trajectory sweep where we can specify a volume that way. It's limited to the helix. But good question. I would have asked the same thing.
Perfect. Thank you so much. So I don't see anything else in the queue. I do want to thank everyone for joining us on today.